Alright, so in this problem, I asked you to solve for the variables. And you'll typically see this phrase when you're taking your standardized test. They'll normally say, not drawn to scale. Have you guys seen those words before?
Yes.
You might be asking, why does that happen? This is a very good problem to show you why. Now, someone asked me, is this a straight line? The answer is no. Because if it was straight, it would be perpendicular to this line. Perpendicular means how many degrees? 90, not 105 degrees. We're okay?
Yes.
So let's... Another strategy I'm doing here is I drew the original problem in one color, and then I can mark up the picture with a different color. So here I have perpendicular lines, straight angles, so this is going to be a 90. Class, that means this one's going to be a 30. And then over here, 90, 45, that means this one is a 45. It doesn't look like it, does it? But not drawn to scale. Do you see that? It kind of looks like a 30, 60, 90, but it's not. Well, I know in an isosceles right triangle that opposite sides of the 45, so same angle, same side. See that? So I'm going to draw this mark and this mark. And that might be a starting point for us. So if these two are the same, that means x is equal to 14. Well, now I have the sides. Let's finish that 45. So I can use my formula or shortcut. X radical 2. How does that work? Remember, across the 45s are equal to x. Now, just because on the picture that's what you're solving for, ignore that. Just look at the number. And again, if it helps you, you can just use a different color. Let me use a different color. X radical 2. So if I know that this x length is equal to a number, that's my starting point. So I would not start here because I have an unknown. But I can start here because I have a known. X equals 14. So this would be 14, 14, 14 radical 2, right? X is equal to 14. So that means my y is equal to 14 radical 2. Now I can use that 14 radical 2 on my 30, 60, 90. So I can just draw my formula, 30, 60, 90. Class, what's the formula?
X radical 3.
What color do you like? Green? So across the 30-degree angle is going to be my x, which we already have one. Across the 60, this will be x radical 3, and across the 90 will be 2x. Class, yes or no? Should I start here? Here?
No.
Here?
Yes.
Yes. X equals 14 radical 2. So if I already know that x equals 14 radical 2, then I can just fill in x into every x value. Does that make sense? So this will become 14 radical 2. This one is x times radical 3. So if I do a substitution here, 14 radical 2 times radical 3. Class, rad 2 times rad 3 is 14 rad 6.
It's 14 only, not 14.
I don't know. Oh, I do see it. I wrote the same number on that side. Raise your hand if you solved my mistake. Good job, you're paying attention. So 14, 14. My fault. So this is 14. It's okay?
Yes.
Okay. Now, if I know that is, oh, that's even easier. If this is 14, then this will be 14 radical 3. And if I put 14 here, that'll equal what? 28. So this is going to be 28. This is going to be, z would be 14 radical 3. So 14 radical 3 and 28. Ah, that made our life a lot easier. So this problem used both of the special right triangles.